And now for something completely different. So, I'm not going to be talking much about anything blockchain related, in fact. I'm going to talk about something that you may need if you are doing any kind of blockchain dependent app, or really, I'll get into it in a minute, but let's just say this is something different. What it is we're going to talk about smart search, and what I mean by that I'll get into more detail in a little bit, but kind of my general point is that in general you probably need something more than just MySQL or MongoDB or whatever your DB is to back the metadata that you guys may be serving up alongside your primary purpose of whatever your app or your company's got. Chances are you've probably got a lot of data you need to deal with. But first, let's talk a little bit about who I am and a little bit about me. Right now, I'm chief data engineer of LoosenWorks, kind of doing a bunch of applied machine learning and data engineering R&D. I've been at a bunch of other places in the past, doing search, interest modeling, profile search, recommender systems, that kind of stuff. Back in the dawn of time, I did algebraic topology and particle cosmology, not even less related to any of this stuff. But in general, it's playing with a lot of data. Who are you guys? I tried to do some research about this, because if I'm going to come talk here, I should at least know sort of what blockchain's about. But since I'm old, I asked my kids if they could tell me a little about it, because that's how you find out how new technology works, right? They weren't terribly useful. It turns out that maybe they're not at quite the right age ranges to fit exactly knowing what blockchain's about. So let's just say I treat it as a black box. But I do know that in particular, you should still care about search because you still have a lot of data. Even if you may call it metadata, it may just be transaction data, it may just be fairly opaque. It may not even have a lot of text. That's fine. You probably still need to be able to serve it up in a way that is useful. And the reasonings for that will depend on your application, clearly. But really, if you don't have a way of doing search, you don't have a data lake. You have a data swamp. And the amount of data that's living out there today on the general kind of cloud world or the enterprise world that's not usable is tremendous. And that's the reason why it's not searchable. To serve up data in a sensible way requires kind of search and recommender systems in some sense, pretty much always. But what is usable search? In particular, it's search that's smart. It actually has some understanding of what users are looking for and what, how to get it for them. But learning what users want requires looking at what your actual users are searching for. And in particular, you need to know what they've asked in the past, what you showed to them in the past, and some measure of how successful your attempts to serve them answers to their questions were. I guess what I'm getting at here is, you have to have a notion of user feedback to have any sensible search today. Maybe 20 years ago, you could get away with your only main signal is something like PageRank or popularity. But nowadays, people expect that there's a level of semantic meaning in any search. If you just think back to what kind of searches you used to do on the internet even 10 years ago, you would have a few keywords and maybe an adjective or something. And nowadays, people ask full sentences of asking how do I find a replacement part for my something, 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 something? And they expect the search engine to be able to answer that question in some sense, even if you've got a bunch of weird prepositions and questions and parenthetical phrases, effectively. And people expect this for every kind of search. No matter what you've got, no matter what your data is, people have been trained, especially by Google, to expect that that's the kind of question they can ask, and it should be handled. And when you don't do that, they just assume your search is broken. One of the customers, one of our customers, we actually do all the search for Reddit now, and 7th largest website in the world, and they had search that had gone through many iterations, and coming to us, they said, we want to make sure that you don't train all of our search based on what people are currently searching for, because really they're searching based on the assumption that our search is broken. Trust us, this is what we feel, and let's retrain them. And you don't want to have to retrain your users to think that your search was broken and now you're giving them something new, because retraining them out of that is difficult. But why do you need to understand what your users are really looking for? And the reason, the kind of example I give for this in kind of the e-commerce space for how do users expect even a very simple search to kind of have meaning in it is, someone does a search on some website that you might be able to recognize the font style and this kind of screenshot that was stolen here. What is someone searching for when they're looking for a garage door opener? Interactive, someone shout out. You're looking for a garage door opener, what are you looking for? What's that? That's not what I would imagine. Most likely I'd imagine, any other? Yeah, maybe, or yeah, they want to either fix it or they want to get a replacement part for it. But in general, if you go on many sites and look for this, in particular, what they actually mean, garage door opener, people think of it like the remote often, like get me the garage door opener. It's this clicker thing that opens the garage door. But the industry that sells these things that fix your door and gets it open, they mean the thing that hangs inside your garage. And it's like a $700 device, not the $3 device that is your remote. But if you actually had a search engine that was really smart and understand what users were looking for, they meant, oh, you mean people search for garage door opener, they mean the remote. But then if the small minority of users that are, say, buying devices and trying to install them in places, they're looking for the actual garage door opener remote, the expensive thing. If you conflate these two, you can alienate your users completely. So you need to have some sort of sense of knowing what the industry meanings are, what the real quote-unquote meaning is, what people think it means, and then also be able to interpolate between those two things. So the way this works on home improvement stores, their search engine, if they're good, as well as on Amazon, is you search for garage door opener, it automatically auto-completes to remote. They're like, you really want the remote? You want to replace that? Or do you need a new thing to install in your new home? If you hit enter on garage door opener, it means you didn't take their autocomplete suggestion and you really want this big device. So this just shows up. If you take the extension and let it go to garage door opener remote, then they're clear that you didn't want the $700 device, you wanted a small little thing to replace because you lost it. And being able to do that requires knowing that people are going to issue these two types of queries. And they seem very similar, and in text search, they look almost identical. Using user feedback has a lot of different pieces to it. The kind of things like regular text-based stuff, tokenization and stop words and handling phrases has been around for gazillions of years. Not zillions, but a long time. Having proper guided navigation, faceting is kind of table stakes. Autocomplete, everyone expects that already sort of works. But nowadays, people really want things like query intent classification, know whether or not you're looking for things that are accessories or devices themselves. If you're looking for transactions on the blockchain, or are you looking for, specific pieces of metadata about a contract? Are you looking for, what are the kinds of things that people are looking for, not at a deep level, like I want to know this particular thing, but broadly, what are they about? Because then that can help guide what kind of facets you want to show if you've got a faceted navigation system. You want natural language understanding so you don't get tripped up with a bunch of, why do I not know blah, 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 blah. You really want the noun phrase at the end, you get some sort of proper syntactic understanding. At a slightly deeper level, there won't be a lot of code in this, but at a base level, everyone does Everyone understands SQL, I hope. Even the business folks understand SQL. Click feedback, in general, is based on the idea that you've got click logs somewhere in your search engine. You've got people who issued a query, they clicked on a doc ID. Group by that, count out the number of times. Store that stuff so that then when the later queries come in, you fetch back up that same query and doc ID and the weights as a triple, sort by weight descending, and start biasing your new search results, biased toward the things that had previous clicks for that particular query. So it's not popularity based, it's popularity for a given query. This of course goes deeper. You can do this on a couple different pivots. If you start aggregating some user ID, which may be a token that is just a cookie, or some sort of session ID. It may not be a logged in user if you've got privacy constraints on your system, but there's going to be often some notion of who's issuing the query so that you can personalize stuff to them later. To do that, you want to actually group up what are the kind of queries they're doing, how recent did it happen, and what were their kind of session chains of one query to the next to the next. More deeply, if you've got user feedback information where users have issued clicks on particular documents, you can start to generate these kind of user document profile sets of this user has clicked on this kind of document or this particular document many, many times. Start predicting in advance that that's what they're already looking for. People often use search as a navigation aid. They're not going to use your drop downs just because they know they can just type something and then they get the results. They expect search is smart. But this kind of thing lets you do personalized search right away, where if you just aggregate together for each user a set of doc IDs that are known to be preferenced by them, issue the search as normal, but then bias all the results toward those results, those that intersect with the ones that the users are always interested in. If they happen to be in the search results for that query, and the user is interested in them, you've probably got an exact hit somewhere in there. This is a monstrous pile of SQL. We don't need to read through it at all. The money shot is down kind of at the bottom that's saying that effectively, with simple matching of your main kind of catalog of data, whatever metadata you've gotten there, some sort of category of the type of document that it is. Maybe it's inside of a store, it's the department of the store, or if it's, categories of different kinds of contracts or different kinds of transactions. You've got that labeled in the documents. Users are issuing queries and clicking on stuff. If you kind of join those two tables together and group by the query that was issued and led to a click on a document in a particular category, you effectively have this notion of transfer labeling, where you thought you had, in the machine learning sense, no labeled data. You just had people issuing queries, they clicked on stuff. But you have labels on your documents. You now transfer those labels onto the queries that were issued that led to clicks on those documents, and suddenly you have a query to category classification set that by itself can teach you a lot about what people are issuing, what the meanings of those things are, in terms of whatever label you happen to have. This is pretty transparent. That category label could be anything sort of categorical on the end, on your main category table. These kinds of clickstream signal aggregations look all the same, but they give you this whole sort of power that really, I mentioned this should be smart search. This is about machine learning. The power here is the most, my favorite form of machine learning. It's called counting. Really powerful, scales really well, highly parallelizable, and frankly, it does a pretty good job. Where does it not do a good job? Well, we'll get to that in a second. Where it does a really fantastic job, they're precision-oriented, they're not kind of recall-oriented, and they're really good on high-volume axes. Your frequent users, your power users, personalization works great for them. Common search terms tend to end up getting the exact results at the top, and popular documents end up getting found for the right things. Vice versa, they're not so great on the long tail. So counting by itself does not work when you only have very sparse counts and the statistics just don't work. And you get a lot of noise. Some things show up that really shouldn't just because they have 3 clicks, and that's 3 times as much as the next biggest thing with as many clicks, which means it's really important, right? No, it's only 3 clicks. Statistics is not good on small counts. So you kind of have to do something a little bit more on the long tail. This is where you get to actually doing any machine learning that really makes any sense. And the archetypical machine learning workflow that I kind of pitch to people is, first, don't worry about hiring a bunch of machine learning experts. Hire data plumbers. This is what I've mainly kept my title as for a long time. I'm a data plumber. Like data engineering, sure, yeah, we do some data science, we do some data engineering. Really, we're data plumbers. We clean the data, we get it into a place where that big data that is garbage gets cleaned up and turned into small data that's very clean. And there's an aphorism in machine learning that I like to go by that, clean data is much better than big data, is much better than smart algorithms. And really that ends up being true. Everyone's got big data these days, and getting smart algorithms is hard. Getting clean data just requires getting some good data plumbers and knowing your business logic, knowing your domain. And then once you've got that, train simple, interpretable, supervised models. Don't get fancy. This is like the first real thing you should probably be doing. So what are the kind of things you'd be doing? After you've done this counting SQL stuff, the models you can do for search are query intent classification for unseen queries. Things both on the long tail and off the end of the long tail. Queries you've never seen before because you've trained classification models on the head of the distribution, maybe the body of the distribution. That gets you a classifier that can now apply to queries that you've never even seen, especially if it's maybe a character-based classification model, not token-based. You can even handle misspellings. You can handle people putting in product IDs and things like that that may be broken down into, or product IDs or transaction IDs or anything that doesn't, if it's not a hash, so you can actually have substrings that have meaning inside a larger string, these can be really good. Once you've got these, we saw at least one of the groupings in SQL was on user ID, document ID, weight. Well, what is a set of user ID, document ID, or item ID, and weight? Well, that's the input to a collaborative filtering system. Those are the wisdom of the crowds that will lead to any recommender system based on collaborative filtering to generate personalization. And then, once you understand the head of your distribution, the tail of your distribution, doing query rewriting by finding a relationship between an item and a query in the tail of your distribution as a variation on something in the head of the distribution, apply the statistics that are reliable on the head to each of the tail queries that are similar to them. And each of these approaches can be done fairly straightforwardly. There's some infrastructure you need to get there, but it's fairly straightforward. But where do you get it? TLDR, buy our products. LucidWorks Fusion, we do have things. This is based on my last slide, so you're not going to get a big sales pitch from me. But most of the stuff in here is fairly straightforward. You can build it yourself on, wow, that auto-completed. It's not Apache Solo, it's probably Apache Solar. It's on here on my shirt. I think I spell corrected myself out there. But Apache Spark and Solar, you could build the stuff yourself. Counting's really easy, SQL's super easy. But the infrastructure to set up a place where you're tracking clicks live in real time, running aggregations continuously, serving them up as part of query pipelines, and providing things like query intent classification, recommender systems, building all the pieces, trust me, it takes a while to do. I've done it in a couple companies now, and you shouldn't have to do this. You need it. Everyone with data, and you've got users searching for stuff, you need this. Buy our stuff, and then you can build things on top of it as well, because it's built on top of industry standard stuff like Spark and Solar. But that's about it. Thanks a lot. Any questions? I don't know if we have time. You can find me on those various places. Yeah.
What do you do if the data are very limited?
Say that again.
The situation that the user data are very limited. There are a small amount of data about the user. It's possible in particular.
Typically, you're going to have a very small amount of. In fact, I made no assumption of any metadata about the users whatsoever, other than you've got some identifying mark about they're consistent. So when they come back again, you can tell it's the same person. Which some privacy-based systems will not allow that to happen. If you've got a setup where you want to allow people to retrieve individual pieces of data, or maybe even search, but they're never identified in any way, and you've don't even let them have, you know, cookies don't even apply. Then you can't do really anything user-based there. You can't do any personalization. You probably can't even do session stuff because there's no cookies even there. So there are places where you trim down all information. Usually, even without a login and no metadata about the user, you have some recurring, the fact that they've returned again. You've got a user ID or some sort of cookie. In which case, you're just aggregating together the past queries they issued, what they clicked on, possibly if your app has some other form of, maybe like they saved their previous things. They want to save transactions they've seen in the past, or they've saved individual, you know, users or keys they're interested in following the activity of. Then your app may do that just for the sense of, you know, stickiness. You want people to come back and use your app. In which case, all you have is the things they've found interesting in the past. That by itself, via collaborative filtering, will provide a huge amount of ability to recommend new things they may be interested in, as well as possible known reformulations of their queries. Because you've seen people that have issued similar queries led to the similar kinds of clicks. And now, when they issue a different misspelling, you know that for them, that misspelling means something different than someone else. So I don't think you need a lot of metadata about the users. You need your own metadata about the documents, and then the fact that the users are clicking on those documents or saving them or issuing some sort of clear signal that they were satisfied with the search result. Anything else? If not, thanks for having me.